The most beautiful equation. At first glance, these 5 symbols have almost nothing in common. One describes nothing. One starts counting. One belongs to circles. One appears in continuous growth. And one shouldn't even exist. Yet somehow, these 5 symbols combine into a single equation. One that has fascinated mathematicians for centuries. It almost looks fake. How can circles, growth, imaginary numbers, nothing, and one possibly belong inside the same equation? Before we can understand the equation, we need to understand the 5 symbols hiding inside it. Let's start with perhaps the most familiar one. Pi. Draw a circle. Now measure its circumference. Next, measure its diameter. No matter how large or small the circle becomes, the ratio never changes. It doesn't matter whether the circle fits on a coin or surrounds an entire planet. That ratio will always be exactly the same constant, pi. So that's pi, a number born from geometry. But the next symbol doesn't come from shapes at all. It comes from growth itself. Unlike pi, E isn't about shapes. It's the number that appears whenever something grows continuously. Population, compound interest, radioactive decay, even the spread of heat. Different problems, different sciences, the same number. That's why E appears almost everywhere mathematics models continuous change. Then there's I, perhaps the strangest number ever invented. Square any real number. It's always positive. So how could any number possibly satisfy this? Mathematicians stopped thinking about numbers as points on a line. Instead, they imagined an entirely new direction. Welcome to the complex plane. Here's the incredible part. Multiplying by I doesn't simply change a number. It rotates it. Every multiplication turns the point another 90 degrees. Now we are finally ready. This equation isn't about arithmetic. It's describing rotation. Watch what happens when the angle becomes exactly pi. Half a revolution. 180 degrees. The point lands here. -1. Add 1. And suddenly, the impossible becomes beautifully simple. But here's what makes this equation extraordinary. It isn't simply correct. It's what each symbol represents. Every one of them comes from a completely different corner of mathematics. And yet, they all meet here. And that's why this equation surprises mathematicians. Not because the symbols exist, but because they have absolutely no reason to belong together. Geometry doesn't usually talk to exponential growth. Imaginary numbers don't usually explain circles. Yet somehow, this equation makes them all speak the same language. Every symbol in this equation could fill an entire university course. 0, 1, pi, EI, 5 ideas, 5 different worlds, one extraordinary equation. Perhaps that's why, after almost 3 centuries, mathematicians still call it the most beautiful equation ever written.